Bismillahirrahmanirrahim. Now we will do the trigonometric identities in AS level. So there are a few more identities in A2, but so far we have just two trigonometric identities which you have to practice or you have to understand, and they are very simple identities. So let's see what you are supposed to do in AS level regarding trigonometric identities. So this is one of them, by the way, we have already discussed in the initial lessons, trigonometric identities. One of the identities that was sin x over cos x is equal to tangent x. By the way, we have already done that, but once again, how is it equal to that? You know, sin x is equal to opposite over adjacent. So if both of them, opposite is divided by hypotenuse and adjacent is also divided by hypotenuse, then opposite over hypotenuse is sin x and adjacent over hypotenuse is cos x. So that is equal to tangent x. Then this is first identity, number one. And now number two, second identity, that is from Pythagoras theorem. If this is a right angle triangle, you know, this is A, B and C, this is right angle, these sides are A, B and C. If this angle is x, then according to Pythagoras theorem, it says that a square plus b square equal to c square. Now, if we divide all these values by c square, then it will be a square over c square plus b square over c square equal to c square over c square. Then this will be a upon c whole square plus b upon c whole square equal to, these are cancelled, that will be equal to 1. Now referring to this figure, a upon c is sin x. Sin x whole square plus b upon c is cos x, and there is a square over here. Okay, now for trigonometric ratios, at least if there is a square on it, then again and again putting a bracket on the ratio, it is an understanding that this square can be written as sine square of x. If you write it this way, it will be considered as this one. So there is no need to put the bracket again and again, and directly you can write it as sine square x plus cos square x is equal to 1. So these are two identities. I write them again. Number one, tangent x equal to sin x over cos x. And number two, sin square x plus cos square x is equal to 1. Just these two identities are to be applied. So during questions in paper, if there is any question about trigonometry, then you don't need to think beyond these two identities. Whatever is there, that inshallah will be solved by applying sometimes one of them, and sometimes simultaneously both of them will be used in a question. So you don't think about anything else. Everything will be solved using them. Now look, what happens that sometimes this identity, especially this one, it can be written in some other form like sin square x is equal to 1 minus cos square x. So if you have in your mind this relation, then sometimes it suits us that sin square x is replaced by 1 minus cos square x. And in some other question, if it is given 1 minus cos square x, then you can replace it by sin square x. This type of things are used in expressions like this. Like if it is given sin square x minus 4 cos x equal to 3 or something else, and it is asked to express this expression in terms of cos x. So we cannot replace this cos x to sin x. That's why it is asked to express in terms of cos x. So this sin square x can be replaced by its value, this one, this value. So that will be 2 times 1 minus cos square x minus 4 cos x equal to 3. Then it will be 2 minus 2 cos square x minus 4 cos x equal to 3. Now changing their place, this is negative. On the other side, it will be positive. 2 cos square x plus 4 cos x plus 3 minus 2. So this will be the final expression, 2 cos square x plus 4 cos x plus 1 is equal to 0. And then sometimes it is asked to solve for x, then considering cos x, let's say if we replace cos x by a, then this will be a quadratic expression as 2a square plus 4a plus 1. So that can be solved by using quadratic formula, and then we find two values of a and then values of x. So this type of applications are there to simplify an equation in terms of a single trigonometric ratio, and sometimes if it is given as 1 minus cos square x, then it can be replaced by sin square x. And it is also used in solving the identities, in the proof of identities. So we will solve few questions that how these two identities are applied. So let's start from here. Express this one in terms of cos x. Now you can see that what I was telling, that this expression is asked to write in terms of cos x. So how can we write it in terms of cos? Four cos square x minus sin square x. You can see that This one is already in terms in cos x. This is to be replaced. So 4 cos square x minus 1 minus cos square x. We discussed just now that sine square x can be written as 1 minus cos square. Sine square x is equal to 1 minus cos square x, and also cos square x is equal to 1 minus sine square x. So in both of the ways we can replace. If the question would have been to express in terms of sine x, then we would have changed this cos square x to 1 minus sine square x. But right now it is 4 cos square x minus 1 plus cos square x. That becomes 5 cos square x minus 1. Here express in terms of sine x. Sine square x minus cos square x. Sine square x minus cos square x. It is asked to express in terms of sine x. So this cos square x now will be replaced by 1 minus sine square x. Then I write it directly. That will be 2 sine square x minus 1. Okay, next, this one in terms of sine, 2 cos square x minus 4 sine x. 2 cos square x minus 4 sine x. Here you can see that this sign cannot be changed to cos. That's why it is asked to change it to sine, because only squares can be converted to from one form to the other, but not without square. So this will be 1 minus sine square x, 4 sine x. That will be minus 2 sine square x minus 4 sine x in order of in descending order of power of sine. So this will be the expression. Okay, next, now it is asked to simplify these expressions. So let's see how can we simplify. This is sine cube of x, sine cube theta. Let me enlarge it. Sine cube theta plus sine theta cos square theta over sine theta. Now look, it is very interesting that what we can do, sine theta is common. Sine theta is common. From here we will have sine square theta, and this one will be cos square theta, and there is sine theta here. You can see that these two are cancelled. Then we are left with sine square theta plus cos square theta, which is equal to 1. So this whole expression is equal to 1. So you can expect this type of interesting things in trigonometry, that huge expression is finally simplified to 1. Okay, now the second part. 1 plus sine theta, 1 plus sine theta plus cos square theta over 1 plus sine theta. Now, if we have to simplify, let's take its LCM. 1 plus sine theta is LCM. This will be 1 plus sine theta whole square plus cos square theta. So it will become now it will be equal to a square plus 2ab plus b square. This is a plus b whole square identity plus cos square theta over 1 plus sin theta. Now once again, if we apply that identity, then this will be sin square plus cos square is equal to 1. This completely, that will be equal to 1. 1 plus 2 sin theta, and this expression will be equal to 1 over 1 plus sin theta. Once again, you can see that I don't know about you, but I find it very interesting that how, having solved that long with many steps, and finally we get an answer equal to a number like 1 or sometimes 2. So here you can see that they are cancelled and answer is only 2. So this complete expression is finally equal to 2 because of interesting applications of trigonometry. Okay, then next, this is prove this identity. Now we have to prove this identity. Let's take it here. Sine power 4, sine raised to the power 4 over tangent theta is identical. When you have to prove an identity, there will be 3 lines here. Sine theta cos theta minus sine theta cos cube theta. Okay, let's take left hand side. Whenever you have to prove an identity, then solve one of the sides, either left hand side or right hand side. If you take left hand side, finally it should be proved equal to right hand side. And similarly, if you take right hand side, it should finally be proved equal to left hand side. So let's see. Sine power 4 theta over tangent theta, that is left hand side, and we cannot do anything with this sine power 4, at least so far. So we change this tangent theta. Tangent theta is equal to sine over cos, but as it is written in denominator, so we can write it cos over sine, cos theta over sine theta. Then one of these sine theta will be cancelled with this one, then this power will reduce to 3, sine cube theta into cos theta. Okay, and the identity, we know that is sine square theta is equal to 1 minus cos square theta. So we have to change this power in a way that we can apply this identity. So what we can do, we can write it this way: sine square theta sine theta cos theta. Now this sine square theta, you can write it 1 minus cos square theta into sine theta cos theta. Now multiplying this sine theta cos theta inside the bracket, we obtain that expression sine theta cos theta minus sine theta cos cube theta. And very interestingly, we can see that it is proved equal to right hand side. So you can say that this is equal to right hand side, and finally you can say that left hand side is equal to right hand side. That is proved. So no need to solve both of the sides. You can solve any one of these sides to prove that. Okay. Now these are few questions. These are few identities. Just look at them and try to prove these identities. I think it will help you to learn. Here you can see that there are 3 lines. That means these are identities. So look at these identities and try to solve them. These are for you as an assignment. And I think I have explained all the aspects about identities used in A levels, AS levels. And I hope that you can now will be able to solve these identities. Later on we will do few more identities from past papers. So by that time I wish you all the best, and Allah Hafiz.